Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in to this video on equations and inequalities. So you've probably done equations many times now. Of course, an equation is just an expression with an equal sign like this. And of course, we want to solve the equation by finding a value that we can substitute for x to make the statement true. Of course, we do this by undoing all the operations that have already been done to x, and we have to do them in the opposite order to BODMAS. So it's just like when you're getting dressed, say in the winter, you have to put on your shirt first and then put on your jumper, and when you're getting undressed, you have to do things in the opposite order. You have to take off your jumper first, you have to take off the last thing you put on, and it's the same as when we are solving equations. So in this equation on your screen, we took x multiplied by 2, then subtracted 7, then divided by 5 to get an answer of 5. So we need to undo what was done to x in the opposite order. So make sure you get the order of operations right, otherwise you'll get a different answer. This equation here looks very similar to the first one, but the order of operations is slightly different, and therefore it has a different solution. So to solve the first equation, the top one, because dividing by 5 was the last thing we did, we need to times each side by 5 first. We do the opposite operation. So we get 2x minus 7 equals 25. Of course, add 7 to both sides and then divide by 2. We get the solution x equals 16. That is the only solution. And if we substitute here for x equals 16, we get a true statement. The second equation, however, slightly different order of operations. What we've done is taken x times by 2, then divide by 5, then subtracted 7 to get 5. So when we're solving, the first thing we undo is subtracting 7. So we add 7 to both sides to undo subtracting 7. Then we times by 5. And then divide by 2. So you can see that we get a different answer here, x equals 30. So it's as simple as that when you're solving equations. So remember, if you have an x on both sides of the equation, as we will in this one, what you need to do is you need to first get x to one side of the equation. So here I'm going to expand the brackets first to do that. So 3 times x, 3 times negative 1. So the way that I get x to one side of the equation is I subtract the x with the lowest coefficient. So here I'm going to subtract 3x from both sides. I end up with minus 3 equals 4x minus 3x is x plus 18. And then, of course, I subtract 18 from both sides and I get the answer x equals minus 21. And you don't need me to tell you whether or not your answers are correct. We can just substitute x here and here for minus 21, and we should get the same number from this expression as from this expression. So that's all for equations, because you probably know this already. So let's go ahead and look at inequalities. So whereas an equation has an equal sign, an inequality has an unequal sign, like less than or equal to, greater than or equal to. An inequality will have one of these signs. Now, the way that you solve these inequalities is pretty much the same as for equations. In fact, it's exactly the same, but there is just one difference that I'll go through in a second. So let's say we have the inequality x plus 2 is greater than 0. So unlike if this was an equation, x plus 2 equals 0, here there are going to be infinitely many solutions, not just one solution. There are infinitely many numbers you can substitute for x to make this a true statement. For example, if you substitute x is 10, you get 10 plus 2 is greater than 0. That's a true statement. If you substitute x is 1, you get 1 plus 2 is greater than 0. That's a true statement. However, I can't just substitute any value for x. If I substitute x is minus 7, I get minus 7 plus 2 is greater than 0. Minus 7 plus 2 is minus 5. Clearly, minus 5 is not greater than 0. So x equals minus 7 is not a solution to this. So how do I write those infinitely many solutions? Well, I'm just going to solve this like I would a normal equation. If it was x plus 2 equals 0, I'm just going to subtract 2 from both sides. And that's what I'll do here. And I get x is greater than minus 2. So I can substitute for x any number greater than minus 2, and that will make this a true statement. We can display all of these solutions on a number line that you would have seen many times before. So I'll just label these. So x is greater than minus 2. What we do is we start at minus 2 and we draw a line in this direction. We drew it to the right because x is greater than minus 2. If it was less than minus 2, it would have gone the other direction. So you put a circle at the start. So I put a circle here. So you colour in that circle if it includes the value, and you don't colour it in if it doesn't. So here, it doesn't include minus 2. X has to be greater than minus 2. Minus 2 is not greater than minus 2. So I'm going to leave this circle uncoloured. Let's look at another example. Let's look at this inequality here. Of course, it's an inequality because it has this less than or equal to sign rather than an equals sign. So there again will be infinitely many possibilities for x, and I solve this as I would if it were a normal equation. So what I said to do on the previous slide, when you have an equation in which the pronumeral, in this case x, is on both sides of the equation, you subtract the pronumeral with the lowest coefficient. Here that's minus 3x. But subtracting minus 3x is the same as adding 3x. So what you do to one side, you must do to the other. So that gives me on the left-hand side 10x plus 5 is less than or equal to 20. Minus 3x and 3x cancel each other out. So then, of course, I want to subtract 5 from both sides, and I get 10x is less than or equal to 15. And then, of course, I need to divide each side by 10. You know how to do this. X is just less than or equal to 1.5. Once again, I can display the solutions on a number line. This time I'm including 1.5 because it's less than or equal to. So I colour in the circle, and because it was less than, I'm going to go the opposite direction this time to the left. And that's what the number line will look like. So any value for x that is less than or equal to 1.5 will make this original inequality a true statement. So I said to you that when you're solving inequalities, you solve them like equations, but there's one exception. And now I'll tell you what that exception is. So the only thing that you do differently when solving an inequality versus solving an equation is that when you multiply or divide both sides of an inequality, you must reverse the inequality sign. And that will be shown in this example here. So 6 minus 2x is greater than or equal to 18. It's an inequality. We want to do the same as we're going to do when solving an equation. So firstly, I would subtract 6 from both sides. And that leaves me with this. But now, in order to get x by itself, I need to divide by negative 2. So, when I divide each side by negative 2, I need to reverse the order of the inequality. And 12 divided negative 2 is negative 6. So the answer here is x is less than or equal to negative 6. The reason for this is that when you multiply or divide a number by a negative, you change its sign. And remember, when you change the sign of numbers, the order is switched around. For example, we know very clearly that 4 is greater than 1, but negative 4 is less than negative 1 if you times each of them by negative 1. The order is changed when it becomes negative. Suddenly the 4 is less than the 1 when we're dealing with negatives. So that's why you need to follow this rule. So the only step in solving inequalities that is different to solving equations is that when you multiply or divide each side of the equation, as I did up here, dividing each side by -2, you must reverse the inequality. So notice on the last example on the previous slide, I subtracted negative 3x from both sides, but I subtracted a negative. I didn't multiply or divide a negative. It's only when you're multiplying or dividing each side by a negative, not when you're adding or subtracting a negative from both sides. All right, hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.